Alright, today we're going to be talking about distance problems. We're going to be talking about opposite directions, and we're also going to be talking about meeting points and some other stuff. So this first question says, two trains leave a station at the same time, traveling in opposite directions. One train travels at 60 miles per hour and the other at 80 miles per hour. How many hours will it take for the two trains to be 350 miles apart? So a lot of people are fine with distance word problems until it comes to opposite directions, and I'm here to tell you that it really isn't as complicated as you think it is. First off, a formula that you're going to have to know in all of these distance related word problems is distance equals rate times time. Now a good way to memorize that is to just look at the word dirt and replace the I with an equal sign. Look at that. D distance, I equal signs, R rate T for time. So now you have a formula. Now let's look at the question. It says one train travels at 60 miles per hour and the other travels at 80 miles per hour. Now it might seem like because they're traveling in opposite directions and you're trying to figure out how long it'll take for them to be how much miles apart, it looks like it's a long process, but it really isn't. What it's really asking you on like the most basic level is just how long until 60 miles per hour and 80 miles per hour makes 350 miles. Think about it. Let's say this is the starting point. This is the train going 80 miles per hour, and this is the train going 60 miles per hour. 60 is less than 80, so that's why I drew the arrow slightly shorter. And this is what's going to happen in 1 hour. From the starting point, one train is 60 miles away from it, and the other train is 80 miles away from it. Now, in 2 hours, that's going to add another 80 miles to this train, and it's going to add another 60 miles to this one. Now, in 1 hour, they're going to be 140 miles apart if you add up the 60 and the 80. How far apart are they going to be in 2 hours? They're going to be 240 miles apart, which is 140 times 2. So you can basically say that their new miles per hour combined together is going to be 140 miles per hour. In 1 hour, we're going to have 80 miles and 60 miles. And the sum of 80 and 60 is going to be 140. So this is going to be the new combined rate of these two trains in terms of miles per hour. Now I'm really doing all of this just so you can really grasp the idea, but all you have to do on the test is just pretty much just write down a small little diagram, distance equals rate times time, and then you just plug in the variables. We know that their new rate is going to be 140, and we don't know the time, that's what we're solving for, but we know that we want them to be 350 miles apart. And we have an equation to solve. 140x equals 350. Divide each side by 140, and we're left with x equals 2.5. Now this is the most straightforward way that you can approach this question. All we did was we added up the rates of two of the trains, which gave us 140 as their new rate. And then using the distance formula, we calculated how long it would take them to be 350 miles apart, knowing that their new rate is going to be 140 miles apart per hour. So I guess an easier way that you could put this is that, as you can see from this diagram, in 1 hour they're going to be 140 miles apart, so their new rate of how many miles apart per hour is going to be 140. I've also seen another way of doing these questions, so I'm also going to be doing that for this. You could start off by putting both rates of the trains into the formula. So first we have the train that goes 60 miles per hour, and that's going to be their rate. And then we have another one that goes 80 miles per hour. Their time, we don't know yet, but we know that they're the same. So we're just going to put x for both of them. And their distance, rate times time, is going to give us 60x for this train and 80x for this one. And we want both of these distances to add up to 350 miles apart. So all we're going to do is set 60x plus 80x equal to 350. 60x plus 80x is going to give us 140x equals 350. Divide both sides by 140. 350 over 140 is going to give us 2.5. And there you go, we put this back into here, and then we can see that it will take 2.5 hours for the two trains to be 350 miles apart. The difference between the two ways that I solved this problem, for the first one, I combined the 60 miles and 80 miles to make their new miles per hour, which is 140 miles per hour, and then I solved from there. But for this one, I put in the trains individually into the distance formula, and then using their distance, I combined them to make 350 and solve from there. So it really just depends on which method you think is going to be faster for you. But for me personally, I think the first method is just a lot faster. Okay, now make sure you remember this because I'm gonna have a question that looks a little bit like this in a bit. Alright, next question. John walked to a park at 4 miles per hour and then ran back at 8 miles per hour. The round trip took him 3 hours. How far was the park from John's starting point? Now, I know I'm using very simple, very easy numbers here, so you might just be able to think about this one and just come up with the answer. But on a real test, you're not going to be getting numbers this easy, alright? So let's just solve it the real way anyways. Alright, so we're gonna write dirt again. Now we got two things going on here. John is walking and he's also running. So let's write that down. So when John is walking, he goes at about 4 miles per hour. We're gonna write that down right here in rates. And then when he runs back at 8 miles per hour, and we're gonna write that down as well. Obviously, we don't know the time, but we are given some information where the question says the round trip took him 3 hours. The round trip basically meaning that walking to the park and running back in total took him 3 hours. So what can we do with that information? We know that these two mystery numbers here in the time column are going to add up to 3 hours. So we can just say that the time for walk is going to be x and the time for run is going to be 3 minus x, because if you add up those two times, you're going to get 3 because the x's cancel out. So now we basically know the distance. For walk, it's going to be 4x. And for run, it's going to be 8 multiplied by 3 minus x. Now let's say that this is P as in John's starting point, and this is also P as in the park. I know that doesn't look very helpful, but John is walking to the park and he is walking or running back to the starting point. Now let's use some logical thinking. This distance is not going to change unless if the park magically grew legs and ran away. What we can do with that information is set these two distances equal to each other. So we're going to have 4x equals 8 times 3 minus x. Alright, now let's solve this. We have 4x equals 24 minus 8x. Now we're going to add 8x to both sides, and then we're going to get 12x equals 24. Alright, and from here, divide both sides by 12, and you get x equals 2. Now, don't just go ahead and write 2 in the answer box, because that's not what they're asking for. They're asking for how far was the park from John's starting point. So they're not asking for a time, which is what we solved for as in x. They're asking for a distance. So now that we know x is equal to 2, we can actually erase that and just write 2 here. And now that we know that x is equal to 2, we know that 3 minus x is going to be 3 minus 2, which is going to be 1. So once you look at that, everything's starting to add up. I mean, literally everything's starting to add up. 1 plus 2 equals 3. How far was the park from John's starting point? We just have to calculate one of these here, and I'm going to be choosing the 4x because it's a lot easier. Honestly, you don't even have to write this down, but, 4 times 2 equals 8. So now we know that John's starting point is 8 miles away from the park. Now this is the last question, and I promise I'm going to make it quick. Now I promise this question is going to be easier because you've already done something like this before. Now how do I know you've already done something like this before? It's because we already did it together. Now let's write down our equation dirt as always. Now I'm going to show you how this question is exactly like the first question despite it looking like it's the exact opposite. Two cyclists start 45 miles apart and travel towards each other. One cyclist travels at 12 miles per hour and the other at 15 miles per hour. How long will it take for them to meet? Now for the first question, if you don't remember, it was about trains going in opposite directions. I didn't really say anything about them going in opposite directions because that wasn't really important like at all. All you had to know was that one train has this rate, the other train has this rate. You add both the rates up and then you make new rates. And you use new rates to see how long it will take for this much distance. And guess what we're going to do with this question? The exact same thing. Because all it's really saying is that we have one bicycle going 12 miles per hour. We have the other one going 15 miles per hour. How long until they make 45 miles? Now, we don't really even have to think about them going towards each other or going in opposite directions because all it's asking is how long until it makes this much miles. Alright, enough with all that yabbling. I'm gonna do this question using the second method that I introduced in the first question. We have the first cyclist at 12 miles per hour, and we have the second at 15. We don't know what the time is, but we do know that the time is going to be the same. And for distance, that's going to give us 12x for the 12 miles per hour one, and 15x for the 15 miles per hour one. And just by doing that, we're already halfway done with the question. Now we're trying to make 45 miles in terms of distance, and we have two things of distance, and we're going to add up the two things of distance to make 45 miles of distance. And I know that none of my grammar really makes sense here, but I don't really care. 12x plus 15x equals 45. 12x plus 15x is going to give us 27x. Now we're going to divide both sides by 27, and we're left with x equals 45 over 27. Now we can simplify that by dividing both numbers by 9, and we're going to get 5 over 3. And that's already our answer. We're going to plug this x back into either one of these, and it's complete. So therefore, it'll take them 5 over 3 hours to meet. But if your question is a little picky and it's asking for the exact time in terms of how many hours and how many minutes, this is how you're going to do that. We can split apart this 5 over 3 into two things. One of them is just going to be 3 over 3, which is literally just 1. So we already have 1 hour set aside, and we have 2 over 3. And all we're really trying to do is figure out how much 2 over 3 hours is in minutes. Now, 1 hour equals 60 minutes, because 1 times 60 equals 60. So for 2 over 3 hours, we're also just going to multiply it by 60. And you're going to get 40 minutes. So 60 multiplied by 2 over 3 is going to give you 40 minutes. Now don't forget this one that we left out over here. We put that back into the 40 minutes. We're going to be left with 1 hour and 40 minutes. So there you go. It's going to take them 1 hour and 40 minutes for them to meet. Thank you for watching this video, and I hope you learned something.